Hello everyone, this is the video lecture for pre-calculus. We're going to be doing section 7.4, graphs of polar equations. Maybe I should have put that up here. Oh well, graphs of polar equations. Okay, good enough. So let's just start with some bigger concepts. First, none of this is on your first exam. I'm going to say it up here. Not on exam. At least on exam 2. So what does that mean? It means that we can use Desmos. Now, I'm not going to pull up Desmos graphing here, but I would say Desmos graphing is what I'm using the entire way. And that's how this section is designed. It's designed that if it says, "Hey, here's an equation. What's the graph?" Or, "Hey, there's the graph. Which equation is it?" Multiple choice, and you just got to use Desmos graphing. So let's start with 741. I've got a graph that looks like this. Well, I'm gonna try. Looks like a heart. Oh, there we go. And it says, which of these four equations, blah, 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 blah. Well, if you keep trying them, eventually you'll find that this is the one that works. Yay! 743. It says R is equal to 5 sine of theta. And, oh, I'm sorry. You didn't see that. You didn't see that. It says, here's the graph. Find out which one. And it goes up here to 5. And guess what? It's 5 sine of theta. Oh my goodness. Wow. It's just a circle. Okay. So 7, 4, 5. They have this really cool rose petal curve thing. It's just flower petal things. And there's 5 of them. And the first one's on the x-axis. And yeah, so it's going to be 3 cosine of 5 theta. Because this goes out until 3. Yay! Okay, let's do another one. I mean, this is your homework. This is going to be a really fast section. And so then this one here, it's a little bit flat here around -2. And then it kind of comes up and it looks kind of like an egg. Yeah, something kind of like that. And it goes all the way up here to 6. I think I need to zoom out a bit to keep this going. Anyways, and over here is at 4. So which one is it? It's 4 plus 2 sine of theta. Yay! Okay. Well, that was easy. Oops. I wanted to zoom out. That was my bad. Hold on. Boop. I think this will be a little bit better. Okay. Close enough. Okay, so this one question's a little different than the others, okay? It's asking for a bit more. And so I'm going to write out what it says. It says, is this symmetric about the polar axis? What they mean by that is like x equal, I'm sorry, not x equals 0, the y equals 0 kind of stuff. That's what they mean by that. Here's another one. Is this symmetric about the theta equals pi over 2 line? And what they mean by that is x equals 0. So it's a vertical line. So they're saying, for the first one, is it symmetric like top and bottom? Top and bottom saying. for this one, is it symmetric side to side? Like here and here, are they the same? And then finally it says, is this symmetric about the pole? And the pole, there's not really, I could just tell you what the pole is 0, 0, I guess. But what they're meaning more so is like, is whatever over here, this, I'm going to just make up a shape. So whatever over here, the same as whatever's over here. Are they opposite of one another? That kind of symmetry. Okay, so these are the questions, right? Looking at this problem, they say, is this symmetric about the polar axis? So is it symmetric here, top and bottom? Are they the same on top and bottom? And I would say no. Okay, symmetric about the pi equals 2 lines. So there's this thing right here. Are they symmetric on both sides? Yes. Okay, cool. Here, hold on. I wanted to get rid of that red line. Yes. Okay, is it symmetric about the pole? Is this corner the same as this corner up here? Are those the same? No. Okay, awesome. So there's my answers. What? Okay. Let me give you what each answer is. So each answer in this particular one is failed test may or may not. Okay. Be symmetric, blah, blah, blah. That's the answer for each one of these. Huh? So, let's just talk for a second. My math lab is not my favorite by any means. I'm looking right at the graph, and I know symmetry when I see symmetry. Okay, it's really obvious for humans. But my math lab is trying to say that we need not to use our eyes, which makes so much sense personally. Instead, they say you need to use a formula. So I got it wrong. And then I did the help me solve it to see what they're even asking for, because it just makes no sense to me. So yeah, I did help me solve it. I guess I'm going to write that so that you know where to go to. Help me solve this. And what did it give me? It gave me a bunch of blah. Here we go. Polar axis. It's that when you plug in an r negative theta, you should get the same as r theta. Huh? For the theta equals pi over 2 line, when you plug in a negative r negative theta, you should get, like, equals, I'm going to say it equals an r theta. What? And then finally, for the pole, when you plug in a negative r, you should get a positive r. Say what? All of this makes no sense, right? Like, what is going on? And I learned how to figure this thing out. And it's not very fun. Let's go back to what they had here. So this was r is equal to 4 plus 2 sine of theta, okay? So what I'm going to do is go through each one of these, and I'm going to see what happens. So I'm going to say negative theta. So wherever there was a theta, I'm now going to put in a negative theta. Now, let's simplify. What happens is that negative can come out to the front because it's a sine. It's an odd function. Now I'm going to ask you, did you get the original? No. Now, that means the test failed. The test failed. But what does that mean if the test failed? It means that it may or may not be symmetric. So I'm going to ask you, why did we even do it if it didn't even tell us anything? I have no answer for that. That's philosophy. Okay, let's do another one. So I'm going to say wherever there's an r, it's now a negative r. And wherever you see a theta, it's now a negative theta. Let's simplify and see if we can get back to the original. So I'm going to move that out. Yep. And then I'm going to basically divide by -1 on both sides, but just everything gets a negative. So -4 and then +2 sine theta. There we go. All right. Hey, is this the same as the original? No. So again, failed test, may or may not. Hey. Anyways, last one. I'm going to say I just have a negative r. Oh, it's a sine. Okay. So is this the same as the original? Even if I move this thing over to the other side, is it going to be the same as original? Nope. So again, failed test, may or may not. Don't use your eyes. Don't be so manual. Don't be human. You gotta play the game. You gotta play the My Math Lab game, don't you? Okay. What I want to do is the same thing back for some of these other ones. So these two in particular are actually going to be really cool. No, I just said the word cool. They're going to be different. And so we had r is equal to, let me just try to get some other ones here. I'm going to go in reverse order. 3 cosine of 5 theta. They're going to say, hey, where's this symmetric? Like, this is all on the homework. I don't know any other numbers. I didn't write them down because I was so upset. But hey, you know what? We're still going to do a couple. So the first test means that I have to make a negative theta and see if I get the same thing. So what if I have a negative theta where the theta was? Funny thing here is that with the cosine, it's an even function, and therefore this minus sign, it doesn't come out. No, it just gets removed. It literally disappears. Now, is that the same as the original? Yes. Therefore, I would say this is symmetric about the polar axis. Okay, awesome. You would say yes about that. Okay, now I'm going to do a negative r, and I'm going to do a negative 5 theta. This disappears, and I have a negative on the front. Is that the same as the original? No. May or may not. Failed test, blah, blah. And the last one, if I have just a negative r, and that's it, just a negative, is this the same as the original? If I move that thing over, no, it's not. Failed test, may or may not. There you go. Let's do the last one here. That was just me trying to, try something here. Let's do another one. Yeah. 5 sine of theta. Okay. So, doing it again. What if I have a negative theta? Well, then that negative can come out to the front. Awesome. Cool. So is that the same as original? Nope. Okay, let's try it again. What if I have 2 negatives? And so then if that minus comes out to the front, you actually do get the same thing. Because what happens is that these negatives will cancel each other out. Did you get the same as the original? Yes, I did this time. So it's symmetric about the theta pi over 2 line or whatever. There you go. Okay, last one. Negative r. Is this the same as the original? Nope. Failed test, may or may not. Whatever. Oh, takes great patience for me to be explaining this because I really don't like it. But hey, there you go. Okay, 2 last problems in this section, and they are completely different, and they're completely easy to get wrong. So there's a graph, and these graphs are way silly. They look something kind of like this, and then you have a 30-degree line, and 1, 2. It's like a little spiral thingy going on or something. It says, what's the radius? You. Yeah, hold on. Let me... Okay, that's... okay. So what's... Yeah, okay. I got it. Thanks. What's the radius? Yeah, you know what I'm talking about. At 30 degrees. And you're going to say, oh, 30 degrees right here. Let's zoom in a little bit. 30 degrees. Where's it colliding? It's at 2. You put 2. You're done with that problem. Woohoo! 7, 4, 49. Okay. So, very similar. It does something kind of like this, but they put these sailboat things in your way. I mean, you know what? I'm going to try to draw some sailboats. They put a whole bunch of sailboats right in your way so that it's so much harder to actually get an answer. They thought they were funny, just putting sailboats all over the place. They thought that was so funny. Okay, so it says, where is it the highest? And I'm going to tell you, you got to look up right here at 90 degrees. So you're going to put in 90 degrees as your answer. Yeah, that's how this works. And then it says, well, how high is that then? How high? And if you go and look, there is a sailboat in your way. So awesome. I put 7 here. 1, 2, 3, 4, 5, 6, 7. And then they said, no, it's 7.5. Of course. Of course. Yep. Sorry I didn't see that with your sailboats in the way. Gosh, I even put on my notes so bad. Anyways, it's a silly problem. Just get through it, okay? And that's it. That's all there is in this section. It's actually really fast. So that's all I got. Thank you very much. Have a great day.